Here we have a sample problem for Module 4. Here we have two masses m1 and m2 where mass 2 is greater than mass 1. The masses are connected by a massless rope hung over a frictionless light pulley. So, the contribution of the rope is ignored since it is massless and the pulley is frictionless, so it does contribute since it does not rotate and produce no inertia that can affect the behavior of the system. After the masses are released, we are asked to find the downward acceleration of mass 2. The first step is we draw an FBD for each mass. For m1 we see that the presence of the rope produces a tension which is also the same for mass 2. Note that the weight of mass 1 and mass 2 are both pulling the rope, so they are in the opposite direction as the tension. From the problem, mass 2 is heavier than mass 1, so it means that mass 1 will move upward with a positive acceleration and mass 2 will move downward with a negative acceleration for its direction. Looking at the FBD for mass 1, there are no forces along the x-axis, so we simply write the sum of forces along x is 0. On the y-axis we see that it is the sum of the tension minus weight 1 equals to mass 1 times acceleration. Rewriting this to get an expression for the tension T, which is equal to the sum of weight 1 plus mass 1 times acceleration. For mass 2, the forces along x is still 0, and for the forces along the y-axis we get a sum of the tension minus weight 1 equals to the negative of mass 2 times acceleration. We then substitute the tension formula obtained from mass 1 to the expression for acceleration. Here we see present the expression for the magnitude of the acceleration, which is an expression of the difference of masses times the gravitational acceleration over the sum of masses. We note that the acceleration here is 9.8 meter per second square, and it has no negative sign since the direction has been provided earlier by the negative sign of its weight, and this expression of acceleration is only its magnitude. The direction of this acceleration according to mass 2 is negative since it is falling downwards. The end for now. For questions and comments you may send them to diyeslearningstuff@gmail.com. You may review the slide on YouTube at diyes@diyeslearningstuff. Note, please do not forget to use your school email. Also write your complete name and class section. Thank you for listening and see next meeting.